Hello, um, good afternoon. My name is David Adiboga Oluwadamnola, and I'm here with my group member.
Hi, this is Sandeep.
Yeah, and our project is all about using machine learning algorithm in reducing insurance fraud. And our instructor is Dr. Rashmi Mishra. So go to the abstract. You need to know about the project. So insurance fraud has existed since the inception of insurance organization. Different types of fraud originated from different crimes, but in most cases, there is an international damage to the insured item or the purpose of obtaining the goods for free. Spotting insurance fraud can prove to be a tedious job, as not every claim to be continuously investigated. Again, this process is not only expensive, but also time consuming. This study proposed a model that utilizes computer technology to build a fraud prevention barrier that not only provides a trusted environment for customers, but also reduce the percentage of such illegal fraudulent activity on a large scale. The keywords we use in our project are fraud detection, unsupervised learning, insurance, policyholder, and machine learning. Now, what's the scope of this project? The scope of this project, we have insurance policies refers to the contextual agreement between an issuer and a policyholder, while the issuer has to pay the policyholder and agree sum of money for the policy, and the policyholder needs to pay a regular premium to the issuer. Traditionally, this system has relied on manual interaction between the transaction parties, which resulted in increased length of time and transaction processing and settlement of payment. This has raised several concerns on the security of purpose due to insurance fraud. Then, this crime caused losses to the insurance providers. To the time of millions and settling fraudulent claims, insurance fraud is carried out by exploiting the numerous loopholes in the manual systems of transaction process and even in fraud investigation. Move on to the next slide. Even though improvements in computing and communication technology has improved and promoted growth on such as automated process in the insurance policy process, this system still suffer from performance bottlenecks. As a result, practitioners and researchers are looking for exploiting futuristic technologies to eradicate the problem of insurance fraud. Data mining and text mining has been traditionally used in fraud detection. Yeah, under our proposed solution, these models will be able to identify potential cases of fraud with high degree of accuracy, since it will help develop heuristics that can point out typical characteristics of a fraudulent claim. The model also helps to assist insurance services providers in verifying the authenticity of insurance claims and improve the speed and efficiency of payment settlement by rapidly cleaning legitimate claims. Well, this technology have methods such as clustering, classification, regression, and prediction. This method uses mathematical algorithms to point out problems, evidence, fraud from available financial data collected by issuers. Successful models for fraud detection has implemented methods such as unsupervised anomaly detection through outlier detection algorithms like K-nearest neighbor or 1L support vector machine, OC, SVM, and clustering analysis. So far, so good. Over the years, many organizations and businesses have adopted computerized information systems to increase their productivity and efficiency operation, of which this data is then leveraged using data mining algorithms to provide useful knowledge for enterprises to improve their operations and increase profit. This method are complicated and consume a lot of time from organizations. Using computerized fraud detection automated the process of fraud detection and improve the efficiency of the overall process. Using machine learning technologies can improve the process of the following used in developing expert systems to detect fraud using specific set of rules, assisting in classification, clustering and segment of data and likes. The following diagram illustrates the flow process of the proposed model. Now, here we start. Then we'll move You can see the arrow points to data batches for training, then data validation, data transformation, data insertion and database, export data from database to CSV for training, data processing, data clustering, get best model of each clusters, hyperparameter tuning, model saving, move to cloud setup, purchasing app to cloud, application starts, data from clients to be predicted, data validation, data transformation, data insertion in database, export data from database to CSV for prediction, data pre-processing, data clustering, models, calls for specific clusters, then we go to the prediction, exports prediction to CSV, and that's the end. Now, the block diagram of this proposed machine learning insurance fraud detection model. Now, what are the challenges experienced during this project? I mean, the main challenges experienced during developing this solution is developing a suitable database with relevant labels to train the developed system to detect fraudulent claim with minimal false positive. Also, these tasks can also be costly and time-consuming for various organizations. It is difficult to create a suitable model for fraudulent claims since criminals frequently change their tactics, yes, because over the years, there's always change in fraudulent tricks and tags. As a result, it's difficult to verify the illegitimacy of a fraudulent claim with absolute finality. The challenge is to develop a specific set of characteristics that can guide algorithms in detecting fraudulent claims. This hinders using supervised models to detect fraud claims. Now, the solutions to these challenges are to avoid the issues of unlabeled data, which this is to maximize the rate of detection of true positives and reduce the rate of false positives. Also, the problem is the cost, time, and reliability of the casual generated labels. So in conclusion, this project proposed to use machine learning to automate the insurance claim process to identify fraudulent claim. This will help to improve the image of insurance services and increase customer confidence in the insurance industry. When implementing this technology, helps insurance companies to identify genuine and fraudulent claims. The model harness the power of data mining to uncover hidden patterns or anomalies in financial data that can be examined and verified against known characteristics of fraudulent claims. This project provides researchers with a research frontiers to improve method or come up with new and effective ways to solve problems. Below are the references of our project. We have 1, 2, 3, 4 of them, as you can see below. This is the list of the contribution table for my group. I have Sandeep, and he did the coding part, the proposed solution, challenges, experience report, and drafting. I and David Oluwadamola did the abstract, problem scope, solution to challenges, conclusion, and reference. It's been a great project, and it gives us opportunity to learn more about our project. And now move to the demonstration. So this is a demonstration of our project. Here comes the requirements. So the requirements, we use Jupyter Notepad or either use Google Colabs, and we use Google Colab. We also use the data, stuff like that. Importing all these necessary libraries. We imported these libraries, as you can see, which is being done. Importing necessary package, importing UpStream, CNF3, import Pagas and SPDs, import Mutability spreads, that import CBOS and SSN, import Mutability. So, and then the code loading the data. So this is the code loading all the data we use. And the best way is to mount the drive on the Colab and then copy the paths for the CSV file, data, PD. For this, and also you need to understand the code. So this place is grab a pick at the data. go. And the output, here comes the output. This is the output of the codes, and then describing the data. We have the print, the shape of the data, data sample. These are the algorithms we use for the output. And then this is the GUI display of the output. And then imbalancing in the data, determining the number of fraudulent cases and explaining where we're using. So this is the output. Only 0.7% fraudulent transaction out of the transaction shows that the data is breached. Yeah, so these are the algorithms which prints out the amount of details and the likes, print the amount of details for normal transaction. This is it, and then so based on the above output, it shows the average money transaction for fraudulent ones is more. This makes the problem casual to deal with. So my colleague Sandeep is going to talk about the codes we use in this project. Over to him, Sandeep.
Thank you, David. Hi, Professor. I have used. I am using the. I'll be showing the code what we have done. Actually, the problem statement is related to the blockchain, but we have used this machine learning technique to solve the blockchain problem about this insurance fraud. So this is the Solidity we have used to, for the better interface, we have used this remix also to show you for the demonstration process. Here we use the Solidity 0.5 function, and we have imported these packages, and this is how the constructor and our main function goes. And each where the data is very processed, and it went through the many stages of validation, and we have many set of functions, and we have six parts of code, and we have integrated all together. And this is the insurance policy, how it is token, and the claim is given according to the status. And we have used many functions, and this is the insurance pool, and we have used some different authorization techniques, whether it's the claim is liable or not, or which we can give like what kind of attributes or features can be added so that it is an authorized or unauthorized claim. So these are the some of the functions what the owner is supposed to get the data from the owner. And we have used some safe math techniques to get the better better user inputs, and all this were done in the Solidity models. And this is how the tokening takes place with the data. And this is the ERC. This is how the data is transformed. So that is how we have got the results, and we have done our project successfully, both me and David all together. So this is our project. Thank you. Have a good day.
Thank you so much. Thanks for the opportunity you gave to us to learn and explore about blockchain. It's an amazing project, though it's taxing, but thank you.
Yeah, thank you, Professor.